All right, welcome back. Today, we're diving into the invisible architecture that powers, well, pretty much our entire connected world. Network topologies. You can think of it as the secret blueprint, the master plan that dictates how everything from your office computers to the entire internet is structured.
I mean, it's a great question, right? We use these networks every single day. But have you ever stopped to think about how they actually work? Like, what's the underlying logic that holds them all together? Well, that is exactly what we are going to map out today.
So, the answer to that question lies in this thing called network topology. And really, the best way to wrap your head around it is to think of it as a visual map. It's literally the blueprint that shows us exactly how all the different pieces of a network fit together. Okay, so here's where it gets interesting. Just like with a real city, there's more than one way to draw that map. We have two main views we can take, the physical and the logical. Now, they're describing the exact same network, but man, do they show us very different things. Okay, so on the one hand, you've got the physical topology. This is like a super detailed street map, right? It shows you the exact location of every device, every single cable, every piece of hardware. But then, on the other hand, you have the logical topology. And this is more like a subway map. It couldn't care less about the exact physical route the wires take through the walls. All it shows you is the path the data takes from point A to point B. It's all about the flow, not the physical cables.
All right, so now that we've got that distinction down, let's actually dive in and take a tour of the most common network blueprints you'll find out there in the wild. We're going to start with the simplest one and kind of build our way up from there.
First up, we've got the most fundamental connection of them all, the point-to-point topology.
And it really doesn't get more straightforward than this. I mean, it is simply a dedicated, direct link between two devices, or nodes as we call them. The perfect example? A phone call. That's a direct connection between you and one other person, period. Or hey, if you've ever plugged one computer directly into another with a cable, boom, you've just created a point-to-point network. Okay, next up, let's look at what's called the bus topology. And for this one, I want you to imagine all the devices are living on the same main street. So in a bus topology, every single device is connected to one common central cable. We call it the bus. When one computer sends out data, it literally travels up and down this main path, and every single device on that bus sees it. It's simple, for sure, but here's the catch, and it's a big one. If that main cable fails, the entire network goes down. Game over.
All right, so we've gone from a straight line, now let's move to a circle with the ring topology.
Now, what's really interesting here is how the data flows. In a ring, data travels in a closed loop, and this is key, always in one direction. Each device basically acts like a repeater. It gets the message and passes it along to its neighbor, who passes it to its neighbor, and so on until it reaches its final destination. It's really orderly, but yeah, just like the bus, it has a critical weakness. A single break in that ring, or even just one computer going down, can bring the whole thing to a grinding halt. Okay, next up is one you've definitely seen before, because it's one of the most common designs out there, especially in modern networks. We're talking about the star topology. I want you to think of this one like an airport hub. Every single device, your computer, your printer, whatever, has its own direct flight, its own connection to a central point, like a switch or a router. All communication has to pass through that central hub. Now, this makes it way easier to manage. If one cable breaks, only one device is affected. But the trade-off is pretty obvious, right? That central hub is a massive single point of failure. If it goes down, the entire network is grounded. No flights in or out. So, what if you wanted a network with just ultimate reliability? One with no single point of failure whatsoever? Well, my friends, that is where the mesh topology comes in. So, the key word here is redundancy. In a full mesh network, and this is wild, every single computer is connected directly to every other computer. Think about that. If one path breaks, who cares? The data has tons of other routes it can take. It is incredibly robust. Of course, as you can imagine, that is super expensive and complex to set up, which is why you more often see a partial mesh. That's where you connect just the most important nodes directly, kind of balancing that amazing reliability with, actual cost and practicality. So what happens when you start mixing and matching these different blueprints? Well, you get a hybrid. And a great example of that is the tree topology. And this really breaks down how it works perfectly. So you start with a bunch of individual star networks, right? Each one has its own central hub.
Then you connect all of those hubs together using a bus topology as a central backbone. And what you end up with is this hierarchical, tree-like structure that actually combines the strengths and, to be fair, the weaknesses of both the star and the bus designs.
Okay, so we've looked at all these different designs, from simple straight lines to these super complex webs. But let's zoom out for a second and ask the really big question here. Why does any of this actually matter?
It matters because the topology, well, it's kind of everything. It's the foundational blueprint that determines a network's speed, its reliability, how easy it is to manage, and how well it can grow in the future. Every single design we've looked at has its own unique set of trade-offs, right? It's always a balance between cost, simplicity, and how robust you need it to be.
Let me put it this way. You just can't build a strong, effective network without first choosing the right blueprint. It is the single most important decision, and it impacts everything else down the line: your efficiency, your reliability, and your ability to scale up in the future.
So, I'm going to leave you with this thought. Now that you've seen all the different architectural plans and you understand the trade-offs, which one makes the most sense to you? I mean, if you were building a network from scratch right now, what would you prioritize? Would it be the pure simplicity of a bus, the common sense structure of a star, or would you go all in for the ultimate reliability of a mesh? The answer you pick, well, that tells you a lot about what you truly value in a connection.